Hello, good evening everyone. So in the last lecture we had studied about the KVL, okay? But in this lecture we'll study about the KCL. What is KCL? KCL is the Kirchhoff current law, okay? Kirchhoff's current law. I told you in the last lecture that Kirchhoff is a scientist name, and on the basis of his name he gave two laws. One is based on the voltage and another one is based on the current. So voltage we had already discussed. Today we will discuss about the Kirchhoff's current law. Kirchhoff's current law is totally based on the nodal analysis. You can call it as nodal analysis also, or you can call it as Kirchhoff current law, okay? So for this I'll tell you in starting the general thing that suppose this is your wire, okay? This is your plain wire, no element is connected between this element, this point. This one is, suppose at this point potential is VA and at this point potential is VB, okay? So this is a plain wire, right? So at each and every point potential will always be same. At this point potential is same, at this point potential is same, at this point potential is same, at this point and at this point. At every point potential is same because there is no element connected between these two elements. So in this case we can consider that VA is equal to VB, okay? Next I am taking another example. Suppose this one is VA and this one is VB, and in between these two points I have connected one resistor, okay? And the current is flowing from VA to VB, okay? But so in this resistor is connected, so the potential there is a difference in potential between point A and point B, okay? As you know that the current always flows from higher potential to lower potential, right? Current always flows from higher potential to lower potential, okay? What does it mean by the higher potential? It's not like that it should be positive always. It means that this value is suppose 220 volt and lower potential means suppose this value is 200 volt, okay? Higher potential is always denoted by the positive sign and lower potential is always denoted by the negative sign. So if the current is flowing from A to B, the current always flows from higher to lower. So we will mark positive here and we will mark negative here, right? So if we want to calculate the value of current, the I would be, that is equal to VA minus VB divided by R, because in this current is moving from higher potential, means current is starting from VA, okay? So VA must be positive and current is going at a position of lower potential, so VB is denoted by the negative sign and divided by the resistance. Clear? Next I am taking it opposite, like suppose this one is VA, this one is VB, and same resistance is connected, but now the current is flowing from VB to VA. So in this case value of I would be VB minus VA divided by R, okay? Next another case I am taking. Suppose one battery is connected between VA to VB, okay? This one is resistance R and this one is battery of suppose 5 volt. I am taking random example. Now your current is flowing from A to B, okay? So what is the value of current in this case? I would be equal to, your current is flowing from higher potential to lower potential, so it would be VA minus VB, higher to lower, VA minus VB, and in between battery is connected, so we'll take second sign of the battery, that is minus 5 divided by R, okay? It is positive and it is negative, so we will always consider the second sign of the battery. Clear this thing? Okay, I am taking another example again. But in this case current is flowing opposite to the previous case. This one is VA and this one is VB. Now the current is moving from VB to VA. Okay, this one is again R5. So in this case the value of current would be I is equal to, again you are moving from higher potential to lower potential, that will be VB minus VA, and we'll take the second sign of the battery, that is positive 5 plus 5 divided by R. Okay, clear this thing? Why I'm telling you, because this would help you in nodal analysis, or you can say Kirchhoff current law. Okay, now we'll discuss the questions related to the Kirchhoff current law. I'm drawing one diagram. Draw this side by side. This one is suppose 5 ohm, 10 ohm, 6 ohm, 7 ohm, 9 ohm, 12 volt and 10 volt. Okay, so in the KCL they have asked you to find current in 6 ohm suppose by using Kirchhoff current law, or they can say by using nodal analysis. Okay, so in the step number 1 we have to determine that how many nodes are there. Okay, like if you remember I told you in the case of mesh, if there are two meshes, right, I told you that if there are two meshes you can take up to two variable only, and we need to solve for two equation, right? Similar with the case of nodes, if we are having two nodes then we'll have two variables. Okay, and then we can take two equation accordingly. So first of all we have to determine that how many there are nodes present in the circuit diagram. So what is the definition of node? You must know about it, that node is a point where more than two branches are connected. Okay, node is a point where more than two branches are connected. Suppose let us consider you are moving from here. Is this a node? No, because here only two wires are connected. Branches means a simple wire. Okay, in this point only two wires are connected, so we can't consider this as node, right? This node, yeah, this is a node because here more than two branches are connected, here three wires are connected, so we are considering it as node A. Okay, here at this point also three wires are connected, so we are considering this it as node B. Here again there are only two wires are connected, so this is not a node. This is also not a node. Okay, this is a node because here three wires are connected, and this is also a node. Clear? So in the next step we'll do grounding across the node. You know, if we'll do grounding, the potential difference across this point would be 0, means VC is equal to VD is equal to 0. Why it is 0? I'm telling you again, because at this point and at this point there is no element connected. As I told you above, if there is a plain wire, at every point potential will be same, right? If it is a plain wire, at each and every point we'll measure the potential would be same. Similarly in this case, at each and every point potential is same. Either you will measure here, 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 because there is no element connected across it, right? So at each of every point potential is same, and we have done grounding. Okay, grounding means you know that at grounding position potential is always 0. So in this case VD is equal to VC is equal to 0. Clear this thing? So step number 1, this is not a step number 1. Step number 1, we have to determine, that how many nodes are present. Okay, in this case there are four nodes basically. One node is VA, one node is VB. These two are the main nodes, okay, and one node is VC and one node is VD, right? These known as if we have done grounding, then it is known as reference node. VC is equal to VD is equal to reference node, okay. So we'll always consider a main node, like this is a node VA. At this point means this is a node A, where at this point potential would be VA, and at this point potential would be VB, okay, and at this point potential is VD, and at this point potential is VC. So wherever we have done grounding at this point, at this particular point where we have done grounding, the potential would be equal to 0, and that particular node is known as reference node. Clear? Now next is step number 2. We have to mark current direction. Step number 1 was we have to determine how many nodes are present. As I told you, there are 2 nodes are present. Basically we'll consider always main node, okay, we don't consider reference node. So there are 2 nodes are present, means 2 variable, that one variable is VA and another variable is VP, okay, we don't consider reference node. Clear? Next step number 2 is the mark current direction in the circuit diagram. So we'll mark the direction of current randomly as per your convenience. It's not like that you have to mark like this only. As per your convenience you have to mark the current in each and every branch, but the thing is, the condition is that you have to mark current separately, like different current in each branch. Suppose in this I1 is flowing, in this I2 is flowing, in this I3 is flowing, in this I4 is flowing, and in this I5 is flowing, okay. So I have marked current separately. Clear? Our step number 2 is also completed. Next is step number 3, that is apply KCL at node A. If you don't know about the KCL, what is the statement of KCL? I'll tell you. KCL is the sum of incoming current is equal to the sum of outgoing current, okay. So suppose this is a node and the current is moving like this. This is the current I1, this is the current I2, and this is the current, suppose I3. The current which is entering in a node, that is known as incoming current. So this is known as incoming current, okay, because this current is entering in a node. If the current is leaving the node, then that current is denoted by outgoing current, okay, outgoing current, because that current is leaving the node. So it's a golden rule, like incoming current is denoted by the term positive and outgoing current is denoted by the negative. It's not hard and fast, you have to denote it by like this only, but I generally told my student like this only, okay. So you can do it vice versa also, no problem in that, but be sure that you remember all these things, okay. So incoming current is positive and outgoing current is negative. Clear? So if we'll apply KCL in this case at node A, here I1 is the incoming current, right? So I1 must be positive. I2 is the outgoing current, so I2 must be negative, and I3 is also the outgoing current, so it also be negative. So we can write down that sum of incoming current, incoming is I1, is equal to the sum of outgoing current, that is I2 plus I3, right? So I am writing down this statement, apply KCL at node A, that is I1 is equal to I2 plus I3. Clear? I1 is the incoming current, I2 is the outgoing current, and I3 is the outgoing current. So sum of incoming current is equal to the sum of outgoing current. Okay, clear? Next is I1. We have to convert the value of current in terms of V by R, because you know that according to Ohm's law I is equal to V by R, right? So what we can write down about the I1, we are moving from node to node. Okay, suppose you are standing at D position and you have to move to A position, because I1 is the current. Now I1, with I1 you are moving. I1 is the current which is starting from VD, right, and it is ending up to VA, because we always consider current from node to node. Okay, so it starts from VD and it is ending to VA. So I'm writing here also I1 is equal to VD minus VA, because we are considering from node to node. VD is a node and it is ending up to which node? VA. From where I1 is starting? From VD node, and where I1 is ending? At VA node. So we will mark VD minus VA. Okay, and I told you if in between the battery will come, then the second sign of the battery will consider. If you will move from D to A, what will be the second sign? That is plus 12 divided by the resistance which is present in I1, that is 5 ohm. Clear? I1 is, I am writing down VD minus VA plus 12 divided by 5. Okay, next is I2. I2, again you have to think that I2 is moving from which node to which node. I am writing down here again. I2 is moving from A node to B node, right? It is starting from A node and it is ending up to B node, because we'll always consider node to node. So I2 is moving from VA to VB, so we will mark higher potential to lower potential, means VA minus VB divided by the resistance which is flowing in, sorry, it is I3, so we can, I'm writing it as I3. Okay, so divided by the resistance which is flowing through I3, that is 6 ohm, right? So I'm marking here I3, that is VA minus VB divided by 6. Now I have to see about I2. Your I2 current is moving from which node to which node? Your current I2 is moving from VA to VD, right? I2 is moving from VA to VD, that is VA minus VD divided by 10. It is this current is starting from A and it's ending up to D, so it would be VA minus VD divided by 10. I'm writing down here VA minus VD divided by 10. I hope it must be clear. Okay, if it is clear, then make the Nodal equation, make the KCL equation for node B by yourself. Okay, next in this case, as you know, VD is equal to 0, so we can put VD value is 0. Then in that case the answer would be minus VA by 12 minus VA plus 12 divided by 5, VA minus 0 divided by 10 plus VA minus VB divided by 6. Now your equation will be in two variable, that is VA and VB. So by taking further LCM we can solve it and take one like we can form one equation, right? Similarly, like this, in this we have make KCL equation for node A. Similarly we'll make KCL equation for node B. Okay, same. Next, apply KCL at node B. Okay, apply KCL at node B. Then the answer would be I3 is equal to, incoming current is I3 and outgoing current is I4 and I5, right? So that would be I3 is equal to I4 plus I5, right? I3 current we know that it is moving from which node to which node? VA to VB. So it would be VA minus VB divided by 6. I think it was, yeah, it was 6 ohm. Okay, then I4 is I4 current is moving from VB to VC, right? So I'm marking VB minus VC divided by the resistance. Resistance is how much? 7 ohm. Okay, plus I5. Now tell me, I5 is moving from which node to which node? Again B to C. So we will mark VB minus VC, and in between there is a battery sign, that is negative. So we'll always consider second sign of the battery now, so that would be negative. So VB minus VC minus 10 divided by resistance. VB minus VC minus 10 divided by resistance. Okay. Similarly, we can put the values here also, like VC is equal to 0. Then the equation would be VA minus VB by 6 equal to VB divided by 7, VB minus 10 divided by 9. Okay, clear? Now you will get two equations. This one is second equation and this one is your first equation. You can solve it further. It's just a simple mathematical expression. By solving it, you will get the value of VA and VB, right? And after getting the values of VA and VB, you can put in this value and you can get the current equation. Like in this, they are saying that you need to calculate the current in 6 ohm, right? So 6 ohm in I3. In the 6 ohm, which current is flowing? I3. I3 is VA minus VB divided by 6. You know the value of VA. After solving the equation, you know the value of VB. After solving the equation, then you will get the value of I3. Okay. I hope your nodal analysis will be clear to you. If it is not, then you can tell me. Okay. I can explain you once more and with another example. Okay then, bye bye.